Crisis. This is a word that we all are fear of as being software developers. Think of a day that all of your work has gone missing just like this. What are you going to do about it? You are going to panic, right? So if you are going to do something about it, how long would it take? To be honest guys, as being in the ops engineering team, we have also faced these kind of situations where we had to spend hours or even days in fixing these kind of situations. So that's why we are here to tell you how to get rid of this crisis situation in just few minutes. So we will be mainly talking on this topic from crisis to recovery in just few minutes, and we will mainly focusing on this concept where automation of infrastructure as code with configuration management. So you may be thinking uh, why you are here and what are you going to learn in the next 30 minutes. So as an advantage, you will learn about configuration management and you will learn about infrastructure as code. As a benefit, you will learn through our experiences, and finally as a value addition to yourself, you can have a good nap in a crisis situation. So myself, Chamara and Krishani will be the presenters for today. So if I talk about the agenda for today, first we will start off giving an introduction to infrastructure as code. Then we will talk about what are the importance of configuration management. Then we will show you some experimental stuff that we have done with configuration management tools. And finally, we will end the session by giving a comparison to major configuration management tools. So what is this infrastructure as code? Over the last few years, many software development and IT departments have adapted the Agile and DevOps approach to IT services provision. DevOps has 4 components that provide a unified development and operation framework for service delivery. These components are culture, automation, measurement, and sharing, or CAMS for short. Infrastructure administrators have taken several development practices such as use of version control systems, automated testing, and deployment orchestration and adapted them to help manage infrastructure. So this approach is known as infrastructure as code. So as the name suggests, infrastructure as code is the concept of managing your operations environment in the same way you do for applications or other code for general release. So rather than manually making configuration changes or using one-off scripts to make infrastructure adjustments, the operation infrastructure is managed instead using the same rules and structures that govern code development, particularly when new server instances are spun up. So think of a situation like this where you have this kind of server setup and each of the servers will have different setups, where one will have Jenkins and one will have Git, Apache, and so on. For a manual setup like this, what you can do is you can just log into one system at a time and you can do manual configurations. It's not going to be a problem. But think of a situation like this where you will have different number of servers for each instance and you will have to change the configuration of each of the server. So in a situation like this, you need to have a central point of control where to handle all these configuration management. So that is where configuration management comes into play. So think of a situation like this where you have a lead developer who's the only one knows in and out of a configuration of a setup. So after some time he's trying to leave the company and your boss will come and ask you to set up the servers as it was before. So what are you going to do in a situation like this? So infrastructure as code allows adapting to infrastructure as code practices provides many benefits. So if I talk about speed and simplicity, infrastructure as code allows you to spin up an entire infrastructure architecture by running a script. It not only you can develop virtual servers, but also you can launch pre-configured databases, network infrastructure, storage systems, load balancer, and any other cloud services that you may need. Also, you can easily deploy standard infrastructure environments in other regions where your cloud provider operates. So they can be used for backup and disaster recovery. You can do all this by writing and running code, and also you can do this quickly and easily for development, staging, and production environment. And also there is this configuration consistency. So when it comes to configuration consistency, IAC completely standardizes the setup of infrastructure, so there is reduced possibility of any errors or deviations. So this will decrease the chances of any incompatibility issues with your infrastructure, and it helps your application to run more smoothly. So limitation of risk, as I said before, a lead is going to leave your company and you need to set up the servers again. Because the code can be version controlled, IAC allows every change to your server configuration to be documented, logged, and tracked. And these configurations can be tested just like code. So if there is any issue with new setup configuration, it can be pinpointed and corrected much more easily, minimizing risk of issues or failure. So if I talk about the increased efficiency in software development, it is very straightforward. The developer productivity drastically increases with the use of infrastructure as code. And finally, cost savings. So automating the infrastructure deployment process allows engineers to spend less time performing manual work and more time executing higher value tasks. Because of this increased productivity, our company can save money on hiring costs and engineering salaries. So as mentioned earlier, our IAC scripts can automatically spin down environments when they are not in use. So it will further save on cloud computing costs. So if I talk about what features should infrastructure as code tools should have, preferably they should support a standard scripting language that allows system administrators and developers to use the skills they learn across multiple tools and applications. Having scripts in a single language that can integrate functions from many different tools and applications is vital for efficient IAC and DevOps workflows. And generally these files are known as configuration definition files, so they has to be in text-based files. Most tools will have a specific name for them like templates, playbooks, manifests, or something similar. Any scripts should allow unattended operations, and they should have error catching code that attempts to continue execution to the required outcome, or if they can't fail, they should gracefully and alert the system admins. And it should support the external storage of the code, where it ensures the scripts can be in the same industry standard version control systems as application code. So if I talk about the methods of infrastructure as code, mainly there are two types of infrastructure as code, push mechanism and the pull mechanism. Push mechanism, so how they differs from each other is that the way the controlling server is configured. In the push mechanism, the controlling server pushes all the configuration into the destination system. In the pull mechanism, the destination system pulls out all the configuration from the controlling server. So if I talk about what are the differences between this infrastructure as code versus automation, so mainly infrastructure as code does is it maintains the configuration or state of the data center infrastructure. When it comes to automation, it is the process for automatically pushing that state into the infrastructure and it maintains it. So if I talk about where this infrastructure as codes, the configuration management tools comes into play in the software development life cycle is in this area, the deployment. So these are some big names: Puppet, Chef, Ansible, and SoulStack. We will be mainly focusing on this in the latter part of the presentation. So I hope that you got a clear understanding about what is configuration management and also what is infrastructure as code. So Krishani will continue from here.
Thank you, Vishwa. As Vishwa explained, infrastructure as code is a valuable concept. And now the question is, how do we achieve this? Or how do we get there? So that's when configuration management comes into play. So what is configuration management? That is the process of systematically handling or controlling changes to a server or a system. The configuration, that's basically like keeping a record or keeping track of your system. So how do we there are multiple ways of doing this configuration management, and one way is shell scripting. Yes. So we do not recommend shell scripting. Why? Okay, let's see. First, we have to write everything from scratch. So because we have to write everything from scratch, it takes time and we can make mistakes as well. And then, since we are writing everything, we need to make sure that it works fine. So we need to debug and testing. No need to say, this takes lots of time. It's time consuming. And then shell scripts are procedural. What is that? That means we need to say how to code. For an example, let's say we need to install MySQL. So then you have to specify all the steps required to installing MySQL. So it is also cumbersome. And then shell scripting differs with different OSs. Let's say you have written something for Linux, but you cannot reuse it for Windows. You need to write something completely different. And multiple ways to write the same thing. So these are the drawbacks of shell scripting. That's why we are moving on to configuration management tools. Why should we use configuration management tools? One thing is that it solves the above mentioned problems, and also there are some benefits that we can gain from by using configuration management tools. First one is quick provisioning of servers. Let's say we need to deploy a new server. So then if you're going to do this manually, it might take hours, maybe days, or maybe weeks. But if you had configuration management tools, then you only take few minutes. For an example, let's say you have a server and throughout some period you have done learnings and you have added new software and you have tuned the system, and suddenly it's gone. So your learnings and your effort, everything is gone. But it won't happen if you have used configuration management tools. Then you can deploy your server exactly the same way it was before. And then quick recovery. Again, let's say you have all your servers working fine and suddenly it goes down. You don't know what happened for an unknown reason. So then what would you do? Of course, you have to find out the root cause of what went wrong. But before that, your highest priority should be to get your services back online. So therefore, you need a replacement server. And if you're going to do that manually, then again, you might take lots of time. That's not a very good way. So the best way is to have a configuration management tool and use that to create a replacement server, because you can do that very fast and it will be accurate as well. Then another benefit is version controlling. We can use version controlling with configuration management tools, because now you have your server set up in a code, so you can use best practices and coding practices with that. With version controlling, we can keep track of all the changes that we have made. And also, furthermore, if you want to keep your servers or the infrastructure consistent, and if someone wants to make changes, you can get them via a pull request. So then a project lead or an authorized person can check if this change is acceptable, then only he approves it, and then only that code will be merged to your provisioning code. So then you know what is exactly in your server, and nothing will goes out of hand. And then replicated environments. This is also something you can do with configuration management tools. You can replicate maybe hundreds of thousands of servers with same exact software. And why is this important? Let's say now a common problem is that developers are they are developing coding in their local environment, and once their development is deployed into the production environment, then comes these unexpected bugs and everything. But it could be avoided if the developer can install, or if the developer can have a virtual machine with that production environment and code within that environment. That means similar to that production environment. So there will be less unexpected bugs when deployed. Yes, and then let's look at the overview of configuration management tools. That means the similar features or common features of configuration management tools. Most configuration management tools are model like controller node or agent or master agent. That's the model they follow. And one common feature they share is automation framework. This is an automation framework where it provides you syntax just like in a conventional programming language. So it consists of variables, loops, conditionals. So you can code like you're using like in conventional programming to make programming easier. And then the idempotent behavior. What's that? Let's say you have in one of your servers you have already installed MySQL, and your code says there in your code there's a step to install MySQL. But if it's already installed, your configuration management tool won't allow you to install it again. So that's a huge benefit. That means configuration management tools keeps track of the state of your resources. So once the desired state is reached, it won't try to do it again. And then system facts. This is again another feature that configuration management tools provides. It gives you this feature where you can specify about the system details such as IP address, network interface, and the operating system versions like that. Why is this helpful? Because according to the specified versions and OSs, it can automatically find out the required packages. So no need of us saying what to install for this OS like that. And then it provides a templating system. We use templating systems in order to reuse. So we don't have to hard code any values. We can use placeholders there, and you can specify your host name or server name and reuse them. And when you're choosing a configuration management tool for your task, just think about the infrastructure complexity, the cost, the learning curve, and check whether if there is enough support community and support is there. And then Chamar will explain you about the existing configuration management tools in market today.
Okay, thanks, Krishani. Now, up to this point, you know theoretically what infrastructure as code means and configuration management. Simply saying, infrastructure as code means you have your infrastructure as a code. So ultimately, you have a code to execute, and your infrastructure will be up and running in minutes. So configuration management comes in automating that process. So I'm guiding you through this practical scenario where as ops engineering, what we have done so far to achieve that automation process. So moving on. Now, we have 4 big players around in configuration management tools, namely Puppet, Chef, SaltStack, and Ansible. So these are the major players out there as configuration management tools. So I'm guiding you through this practical scenario by using Puppet examples because what we have really experienced or practiced here is through Puppet. Now, Puppet is used by major players like Cisco, Salesforce, VMware, and PayPal. So this slide is to show you that the importance of configuration management. Why? These companies know the recovery process of being coming out of these crisis situations. So using this kind of a configuration management tool, they are able to come up with the crisis situation in minutes because they can respond their servers and their environments in minutes using these kind of tools, right? So this slide shows our setup, a simplified version of our setup where we have used Puppet to automate our recovery of process. Now, you can see a Puppet master there. I would like to say that when you install in Puppet, there's a master agent architecture where you have a Puppet master to be set up first, right? So it's in a different dedicated server, and all the configurations, main configuration and other configurations that are related to a process or company will go there with the Puppet master server. And let's, for an example, say that we have several Pulse API servers, Pulse front-end servers, and maybe there are many servers. For simplicity, I'll take two. Then we need to install something called the Puppet agent in each of these instances. So Puppet agents will time to time pull all the configurations from Puppet master. We have all the configurations set up in the Puppet master already. Now, let's say that the Pulse API want Node.js and Redis, for instance, and Pulse frontend needs Node.js, Redis, and MongoDB. So the idea is now we have different environments, different requirements, different application dependencies. Before that, I would like to say that there's something called Puppet Forge. So Puppet people have provided us some customized repository on their own to install some software through them. Let's say MySQL, Node.js, MongoDB, as Krishani said. So if we are going to install, let's say I have a server, I want to install Node.js. And if I use the Node.js provided by this Puppet Forge, I just need to write a simple command as install Node.js. So the benefit really gained through this is that if, say, as Krishani said, it is OS dependent. So if you write that command, it will install Node.js in your CentOS, Red Hat, maybe Windows system. So you don't need to specify any dependency there. So if you're gonna write a shell script there, you have to specify everything there. So that's the simplicity that we gain through these configuration management tools, right? Now, if we want to, let's say we face a crisis situation, our all Pulse API servers, front-end servers, and other servers are gone. So now we are in a panic situation. Not anymore, because what we need to do is set up a Puppet master. Already there are all the configurations that we have provided. I'll guide you through this in the next examples, how we provided those configurations. Now what you need to do is you get some new instances and install Puppet agents there. And all the Puppet agents will pull configurations from that Puppet masters, and all the servers will be up and running in minutes, right? So that's the advantage that we are gaining. So you don't need to manually SSH to or remotely connect to those instances and manually install all the softwares or your dependencies or copy configurations. If you want to go to do that in manual way, so let's say that we have 100 servers there, and we need to manually go to remotely log into 100 servers and copy configuration. For sure, you will definitely make a mistake in copying configuration and installing different environments. So if you are in a panic state, crisis state, so you can't do that. So recovery in minutes will become recovery in days. So that is what we are going to avoid here. So this is the simple structure that I'm going to explain. So site PP, don't get confused. Site PP is like a main script running in Puppet master. So site PP will contain all the code, and this is to modularize our code. So let's say we want to install Node, Mongo, Redis, and other software. So they will go under core directory modules. And if we have configurations, we are separating them into different modules as, let's say, Pulse Writer and Pulse Reader. So this is the site PP or the main configuration file. So the idea is not to guide you through Puppet here. So that is not the idea. So you can go through different configuration management tools. I'll just go through these. So if you can remember that there were two servers as Pulse API servers and Pulse front-end servers. Now what we have simply said here is that install Node.js and Redis.js in Pulse API servers, and copy this Pulse Writer configuration files, right? If you have Pulse front-end servers, install Node and MongoDB, and copy Pulse Reader configuration. So that's your custom installations that goes here. If I am a Pulse API server, I am going to execute this code block. That's it. If I am a Pulse front-end server, I'm going to execute this code block. So that's very handy way of doing that. If you are going to write a shell script, you will waste your time, and still you need to debug this for 100 times, maybe. So this is how we have installed Node.js. But the reason for using a custom script is that sometimes we want custom Node.js packages. So we are specifying Node.js 8.0 to onwards. Sometimes Puppet Forge contains outdated packages. So that to avoid that, we use custom scripts, and it is already enforced there that we can use all the custom script as well in configuration management tools. So this is not to guide you through the installation process or writing scripts. So this is the same thing that what we have tried to install MongoDB. So moving on, this is the part that we copy the configuration to our servers. So in our application servers, in order to run an application, there should be configurations. So there are different configuration. Configuration in test environments may be different to configuration in development environments and production environments. So there are differentiations. So we have specified all the things here. So just things like creating directories and copying certain files to those directories. And the important is that Puppet, any configuration management tool can rule any of these operating systems. If it is a Linux machine, Windows, Mac OS, Oracle, or FreeBSD, nothing will prevent them from executing. So as a summary, what we gain through these configuration management tools, it's a consistent configuration. Consistent means if you have 100 servers, 500 servers, doesn't matter, the process is automated, you get a consistent configuration placement in all the 500 servers because there's no human intervention there. It's all automated. If we are going to do it manually, for sure we are going to do a very bad thing there because we are in a crisis situation now. So we can't do that manually there. So less configuration mistakes, it's obvious. So you can manage app configs, less time with test and debug. As Krishani said, these Puppet scripts are well tested, so we don't need to spend more time on testing and debugging. So you can deploy frequently. Of course, you can, if you have a deployment, you just run the script, it will work, right? So less downtime, obvious. So this is what we have achieved. So less downtime means if you have a crisis situation, you can make your servers up and running in minutes. So here, I'm going to compare some major configuration management tools out there because you guys can decide what to use in your own environments and teams. So when we talk about Puppet, SourceStack, and Ansible, they are all highly scalable. That means any of these configuration management tools can handle maybe 100 VMs, 500 VM. It doesn't matter. They support that high scalability. When talking about setting up, Puppet, SourceStack, and Chef, they follows a master server architecture or master agent architecture. So you need to have a master server, and you need to install agents in all the instances. But as an extra feature in Ansible, you have a master agentless architecture where you don't need to install agents in your instances. You need to have a Ansible master setup. Then we need to specify all the IPs in that Ansible master. So the Ansible will go and SSH all these Ansible agents, and he will automatically do the configurations there. Availability, high availability can be achieved through all the configuration management tools. Why? If they support multiple master setup. So if the primary master goes down, the secondary master can easily come up and become the primary master. So highly scalable, so you don't need to worry about crashing there. In management, Puppet follows, if you can remember the syntax, it's a bit new, right? So it's a Puppet domain-specific language where there's a bit of learning curve, right? But if you go through SourceStack or Ansible, it's YAML, it's close to English, so the system administrators will find it easier to code there. In Chef, it's much difficult because you have to have some idea about Ruby language as well. In interoperability, all the servers can handle any operating system in the world, but specifically mentioning these servers can be only installed in Linux or Unix machines. Windows doesn't support these masters, but agents can be run in any of these machines. When we are talking about configuration mechanism, as Vishwa said, there are two mechanisms as pull and push mechanisms. Pull means there are master agent architecture. No? So the agents are pulling configurations from their primary master. So that's the pull mechanism. And push mechanism means that master is pushing configurations to its agent. So Ansible is a push mechanism server. Now, pulling up Google Analytics data for past 5 years, I found out that Ansible is gaining trend in the market. There are two big reasons for that because of this Ansible agentless architecture and the low resource consumption of Ansible. But the reason we use Puppet in our experiments is that Puppet is a more matured tool, and there were so many resources, tutorials, and community support that provided by Puppet, right? But we are going to use the Ansible as configuration management tool in our next projects to test what we are going. So you guys are feel free to use other configuration management tools and share your knowledge with us. And if you have further clarifications or help, you guys can come to us. We are in the 5th floor. Ops engineering will be more willing to help you. So that's the end of the presentation. Thank you.